All right, welcome back everyone. Let's look at the answers to the Now You Tried problems where we are simplifying the following products of rational functions. The first example we have here is x squared plus 9x plus 14 over x squared plus 6x plus 9 multiplied by x plus 3 over x squared plus 7x plus 10. So what we're going to do is take the top one there, x squared plus 9x plus 14, and factor it. Draw a fraction bar, and we want x plus something, x plus something. I know they're pluses because everything's positive up there. And 7 times 2 would be 14, and add to 9. On the bottom, we have x squared plus 6x plus 9. Look to factor these. We need an x in the first position, and I think a plus 3 and a plus 3 will give us the 9 on the end, and they add to 6. So that's good there. For the second fraction, we have x plus 3 over x squared plus 7x plus 10. The top obviously doesn't have any factorization there. It's already linear, so it's not going to factor in any way. There's no greatest common factors. The denominator, we have x squared plus 7x plus 10. That does look like it factors. So we've got x plus 2 and x plus 5. Double check. 2 times 5 is 10. 2 plus 5 is 7. So we are good. Now we'll look for common factors, top and bottom. Looks like we can cancel an x plus 3 and an x plus 2, top and bottom. And that looks like it. So on top, we're now just left with the x plus 7. On the bottom, we're left with x plus 3 times x plus 5. Now we could leave it here. Oops. This is good. And then we can optionally go ahead and multiply that bottom out to get x squared plus 8x plus 15. All right, that's it for the first one. For part B, we have 5x squared minus x minus 4 over squared minus 105x times 15x minus 18x squared over 25x squared minus 16. So it looks like we've got some harder factorization problems here. Let's just do one at a time. The first one that we have, top left, 5x squared minus x minus 4. Well, we need a 5x in one position and an x in the second position. And then our last numbers need to multiply to be 4. So I can either do a 1 and a 4, or I could do a 2 and a 2, or I could do a 4 and a 1. So those are our options. And let's just see if we did, we need a negative and a positive. Say I did a negative and a positive here, we'd get 5x squared minus 20x plus, minus 20x plus x. Those are not going to add to negative x, so that's no good. So let's switch to minus 1 and a positive 4, but that's just going to be a positive 20 and then a minus x, and that's still a 19. So that's not going to work with those in there. Let's try the minus 2 and plus 2 options. This is going to give us a 10x minus 2x, so that's an 8x. If we switch the signs, it would be a negative 8x. So the 2's aren't going to work. So we've got to use a 4 and a 1. Let's make sure that we've got the signs right. I think this will work. We're going to have a plus 5x and then a minus 4x. So that's the wrong sign. That'll give us a positive x in the middle. So let's just change the signs here and check one more time. Plus 4 minus 1. This will be a minus 5x and then a plus 4x and then minus 4. So that will add up to the negative x in the middle. That minus 4 is good. So that is the correct factorization. All right, on the bottom, let's see. Are there any common factors? I know I can pull out an x. I'm trying to think. 126 and 105. let's see if we can find any common factors here. 2 doesn't go into both, but 3 does, right? Because 1 plus 2 plus 6 is 9, so 3 will go into that. 1 plus 5 is 6, so 3 goes into that also. So let's see, 3 goes in here 42 times, right? 3 times 40 is 120, and 2 times 3 is 6. 105 is going to be what? 35. 3 times 35, that's 90, and 15 is 105. That's cool. Let's see if the 42 and the 35 have anything in common. We've got 6 times 7 is 42, and then 5 times 7 here. Yeah. So let's play with these. This is the problematic part of these, is there's just so much like arithmetic and like simplification that we could do. The 3 times 6 is 18 times 7 would give us 126, and over here we have 15 times 7. Oh, that's not. I want to keep the 3 and the 7. Sorry, the 5 and the 6 are different. It's 21 times 6. There we go. And then 21 times 5. So we can factor out a 21 from both of these. And we'll be left with x minus, oops, we'll be left with 6x minus 5 on the bottom there. Ooh, that's a tricky one. On the top right, 15 and 8, 3 can go into both of those. We can pull out a 3x. We'll be left with 5x minus 6. That's interesting. That's similar to this, but it's the opposite, so it doesn't quite work. On the bottom, this is a difference of squares. This is 5x plus 4, and then 5x minus 4. And then we'll look for a reduction. And let's see, the x's can cancel, top and bottom. The 3 and the 21 can cancel. Divide them both by 3, we get a 1 and a 7. And then the 5x plus 4 can cancel, top and bottom. So it looks like what we're going to get is x minus 1 times 5x minus 6 on top, and then 6x minus 5 times 5x minus 4 on the bottom. And so that's fine for a final answer. We can also go ahead and multiply these out. This will be 5x squared minus 6x minus 5x plus 6 over 30x squared minus 24x minus 25x plus 20. And then on top we'll have 5x squared minus 11x plus 6 over 30x squared minus that's 49x plus 20. So that one's definitely got teeth to it, right? We had this process right here of just realizing that 5 or 21 went into both of those so that we could factor it out. That was a little bit of a chore there. Let me do that one more time. 126x squared minus 105x. Let's just first note that 3 goes into both. So if I pull out a 3x to start, then we'd be left with 42x minus 35. And then we can pull out the 7, and then I'd be left with 6x minus 5. So we can kind of see how we could step through it like that, and that would give us a 21x times 6x minus 5. So that might be a little helpful for seeing how we can get through that. All right, let's do the last one here. And can I also just say, as far as that goes, like these factoring and dealing with this arithmetic, this is a skill that improves with time. Don't feel bad if that's something that you struggle with. That's kind of expected. And by challenging you with these kinds of problems, then you get better at them by looking at them and conquering them, even if it takes a while. Every time you do it again and get challenged, it improves your ability. So don't shy away from those challenges. I know they can be challenging, but that's part of the learning process. That's part of what gets us better. All right, this last one, I'm actually going to do, let's see if we can reduce the numbers at least. The 3's can cancel top and bottom. I'm sorry, let me read the problem. We have 5yx over 3y times 3y squared x cubed over 25x to the fifth. And so I want to look for any sort of reduction that I can do right away. The 3's can cancel. Looks like there's a y on top and bottom that I can cancel. The 5 and the 25 can reduce to a 1 and a 5. And then I can also take that x on top and cancel with the x to the fifth to make that an x to the fourth. Oops. Down there. Let's just do that and then see what we have at that point. There's actually another reduction here. We have y squared times x cubed on top over 5x to the fourth. So the x's we can continue to reduce. We have x cubed on top, and then we can cancel 3 of them in the bottom to get x to the first there. So this will give us y squared over 5x when we're all said and done. All right, I hope you guys kind of like those. They're once you get your head wrapped around, it's not so bad. Used to them and be okay with seeing those multiple variables all in the same problem. That's just for helping us understand our reduction rules and just practicing how we can cancel things top and bottom in that little bit more abstract way. All right, nice job, everyone. That's it for this video. Thanks so much for watching, and we will see you soon.